Dear friends, welcome to Bond with RK Chemistry YouTube channel. In this video, I am going to explain the Part 3 of General Organic Chemistry. These are year-wise questions from the lesson General Organic Chemistry. The increasing order of basicity of the following compound is. This is a NH2 group which is responsible for the basic nature of this molecule. Here also we have NH group. Here you have lone pair of electrons. Here you have lone pair of electrons. Here also we have lone pair of electrons. Here we have lone pair of electrons. More the availability of lone pair of electrons, more the basic nature. Suppose if you take this molecule, here there is no conjugation effect, but here the C double bond, C, this one is the electron withdrawing group. The sp2 hybridized carbon withdraws electrons, so there is a decrease in electron density on nitrogen. So when compare basicity of NH2 with the C double bond NH, this one has less basic. But if you take this one, here there is a participation of lone pair of electrons in resonance. So there is a delocalization of these lone pair of electrons, and these electrons comes here. So you have this type of structure. You have NH2 plus, and here you have NH minus. It has two lone pair of electrons. Here there is an increase in basicity. Since nitrogen has one of the resonance structures of third molecule has negative charge, it can easily, readily donate electrons. So this one has more basic nature. And in this case, you have two NH2 groups. There is a participation of these two lone pair of electrons in resonance. So fourth one should have more basic nature when compared with third one. And next one is first one, and the next one is second one. So third, 4, 3, 1, 2. This is the order of basic nature of these molecules. The increasing order of reactivity of the following compounds towards aqueous hydrolysis is. Okay, aqueous hydrolysis, this one depends on the leaving ability of these groups. So this is the Cl, and this is the group, and OMe and NH2. More the leaving ability of these groups, more the rate of hydrolysis, aqueous hydrolysis. Let's take these leaving groups Cl minus and C double bond O minus, and this one is OMe minus, and this one is NH2 minus. Let's take the conjugate acids of these groups HCl, and this one is RCOOH, alcohol, carboxylic acid, and this one is alcohol, ROH, and this one is ammonia. We know the acidity nature. HCl greater than RCOOH greater than ROH greater than NH3. More the acidity of an acid, less the basicity of conjugate base. So this is the basicity order. NH2 minus is more basic. Cl minus is least basic. The leaving group ability, less the basicity of a group, more the leaving ability. So which one has more leaving ability? Cl minus has more leaving ability, and the next one is O minus, COO minus. The next one is OMe minus and NH2 minus. The least or the poor leaving group is NH2, and good leaving group is Cl minus. So the order will be 1, 2, 3, and 4. The chiral compound among the following is, this one is alene. Alene molecules, alenes can exhibit chirality due to having chiral axis. So here you have two equal groups, Cl and Cl. In alenes, the molecules exhibit chirality when these two groups should be different. A naught is equal to P. Here Cl and Cl. Here you have. It's not alene. You have three pi bonds. If the molecule has 2 pi bonds or 4 pi bonds or 6 pi bonds which are continuously then the molecule is chiral. But if it has a odd number of pi bonds, 3, 5, 7, these are not chiral. If you take these two, it's a allene, and these two are different, so this is optically active. In this case, the biphenyls also can exhibit chirality due to having chiral axis, but in this case, you have two same groups. So here there is a plane of symmetry, so it's not a chiral molecule. So which one is optically active? This one is optically active. The increasing order of boiling point of the following isomer hexane is BP is directly proportional to surface area. More the surface area of the molecule, more the boiling point of the hydrocarbons. So first one has more surface area. First one, this one has more surface area. Next one is second. And next one, this one has more surface area when compared to third. So this is the order 4 and the least one is third. So what is the order? 1, 2, 4 and 3. Identify the compound having carbon with highest oxidation state. Okay, let's take the structures. C, A, H, H, H. Hydrogen is less electronegative. So when you cut this one is plus, plus, plus and plus. So you will get 4 minus. And if you take SCOH, C double bond O, H, H, and this one is plus 1, plus 1. Here oxygen has 2 bonds, so minus 2. So here you will get minus 1, minus 1. Due to oxygen, you will get plus 2. So the charge will be finally 0. But if you take SCN, HC triple bond N, here when you cut this one is plus 1. Since nitrogen has 3 bonds, minus 3. Due to nitrogen, you will get plus 3. Due to hydrogen, you will get minus 1. So the total will be plus 2. Here the carbon has plus 2 oxidation state. Here the carbon has minus 4. Here the carbon has 0. CH2Cl2. Hydrogen, hydrogen, chlorine and chlorine. Chlorine minus 1, plus 1 and plus 1. So due to hydrogens you will get minus 2. Due to chlorines you will get plus 2. So finally 0. So which one has highest oxidation state? In HCN, carbon has highest oxidation state. The aromatic systems among the following are: this one is a planar 2-pi system, and let's take this one O minus, and this one is plus. It's a 4-pi system, planar 4-pi system. It's not planar; it's a sp3 hybridized carbon, so it's not planar. It's a non-aromatic. And here 1, 2, 3, 4, 5, 6, 7, 14 electrons are there. 14 pi system. It's a 4n plus 2 pi system. And planar 4n plus 2 pi system. It's a aromatic. This one is aromatic. This one is aromatic. Okay, this one is a 4 pi system. Planar 4 pi system. So it's an anti-aromatic. It's not planar. It's a non-aromatic. So this is the correct option. D is the correct option. The IUPAC name of the following compound is. In this molecule, we have to give numbering in ring, and also the ring, in this ring, the double bond should get least number, and the substituents should get the sum of least number. So 1, this is a 2, this is a 3. At second position, we have methyl group. Third position, we have vinyl group. So the name will be 2-methyl 3-vinyl. The ring contains 5 carbons, cyclopentane, and at first position you have double bond. It's a cyclopentane. So this is the correct option. The increasing order of energy of the following conformers is. The conformers of cyclohexane are given. This one is off chair. This one is a twist form of cyclohexane conformer. This one is volt. Okay, we know the energy order. If you take stability order, we know the stability. This is the stability order: chair, is more stable. Next one is a twist. Next one is boat, and next one is off chair. We know the relation between stability and energy. More the energy, less the stability. Less the stability, more the energy, less the stability. Less the energy, more the stability. Okay, energy is indirectly proportional to stability. So the stability order will be exactly reversed. Half chair greater than, boat greater than, twist greater than, chair. Chair has least energy. Half chair has highest energy. Here, first one has highest energy, and next one is boat, next one is a twist. So this is the correct option. Among the following compounds, the one that is the most soluble in water is. We know that as the length of the chain, as the number of carbons in the alkyl chain increases, the solubility of alcohol decreases. Here this one has two carbons, and here this one has three carbons. Here also three carbons. Here we have four carbons. So first, this one is ethyl alcohol. Ethyl alcohol has two carbons, less number of carbons. So this one is more soluble in water when compared with the remaining alcohols. Okay, molecules given, we have to find out configuration. This oxygen first, second, and third, and fourth. Okay, let's take a second one. This one is OH. OH. This one is hydrogen, and this one is O, and this one is carbon. Here O carbon, and here you have carbons. So this one gets first priority, and OH gets a second priority. This one gets third priority. When you connect 1, 2, and 3, and hydrogen is below to the plane, away from the viewer. So when you connect the 1, 2, 3, there is a clockwise. So the configuration will be R. Let's take this one. Here you have above the plane H, and below the plane OH, and this one gets first priority, and second priority is this one, and the third one is this one. So when you connect this one, 1, 2, 3, anti-clockwise, hydrogen is above the plane. Here this one is first, and this one is second, and this one is third. You are getting anti-clockwise, hydrogen is above the plane, anti-clockwise, you will get R configuration. So second R, 2R, and 4R is the correct option. Identify 1R, 2R in 1,2-diphenyl ethane, 1,2-diol. What is the correct option? Here this one gets first priority, second priority, and this one is this one gets second priority, and this one gets third priority. OH, next one is CO. CO, next one is C double bond C. So 1, 2, 3 connect 1, 2, 3, you will get R configuration as the first position, and here 1 and 2, this is the 1, OH is 1, and this one is 2, and this one is 3. When you connect again, you will get clockwise, and H is away from the viewer. This is the H, so you will get R. 1R, 2R is in this molecule. Among the following, the compound having the most acidic proton is. Okay, here this is the reference CH3, CH3, and CH3. The electron withdrawing group C double bond O, and alkyl group, and CN, and NO2. Okay, among these groups, NO2 is a strong electron withdrawing group. So as the electron withdrawing nature of electron withdrawing group increases, acidity increases. These protons are more acidic. IUPAC name of the following compound is. We have to give numbering. This is the main function group. OH is the main function group. We have to give numbering from this carbon. 1, 2, 3, and 4. So 4 amino, 2 fluoro, hydroxy, benzene. This is the correct option. Which of the following will not exist in the inert form at all in CHCl3 solution? Here we have to find out whether the molecule has alpha carbon to the C double bond O group. Here let's take A C6H5 and C double bond O, CH2, and C double bond O. Okay. For enol form, it should exhibit keto enol tautomers. You know the condition for keto enol tautomers. The carbon which is alpha to the C double bond O should have all hydrogens. So here you have alpha hydrogen. In this molecule also you have alpha hydrogen. In this also you have alpha hydrogen. But if you take this molecule, C double bond O, and this one is CH3 three times. At alpha position there is no hydrogen. This is the alpha carbon, no hydrogen. Here also phenyl ring. In phenyl ring also there is no alpha hydrogen. So this one cannot exhibit enolic form. Maximum number of stereoisomers that the following molecule can have is. This one has the mirror image and non-superimposable mirror image. That is, this is a non-superimposable mirror image you have. Okay. So this molecule has two stereoisomers. The two are anisomers. This is the correct option. The least acidic amine among the following is. Here, due to aromaticity of pyrrole, there is a participation of lone pair of electrons. So there is no availability of lone pair of electrons. This one is less basic. Here also there is a participation of lone pair of electrons, but this one has lone pair of electrons. So these lone pair of electrons will not participate in resonance. So these electrons are available. And here also there is a delocalization, but when compared with this one, there is a less delocalization. Here there is no delocalization. So since the lone pair electrons which are on the nitrogen are participated in the aromaticity, this pyrrole has less basic nature when compared with the remaining molecules. The CC bond length in benzene is, we have alternative single and double bond. When you take resonance structures, you will get this is a resonance structure. When you take resonance hybrid, this is the average of these two molecules. So in one resonance structure, this one is single bond. In another resonance structure, it's a double bond. When you take average of single bond and double bond, you will get the bond character in between single bond and double bond. So it is longer than CC bond length in Italy. So since there is an increase in bond length, the bond length is in between 2 and 1. It should be shorter than single bond and longer than C double bond C. So this is the correct option. The molecule with the highest dipole moment among the following is. This is also an application of aromaticity, in which case there is a aromaticity. When you push these electrons, this one is minus, this one is plus, and here minus, plus. But in this case, you get minus and plus. Here you will get a cyclopropenyl cation. It's aromatic. When you get aromatic, then that molecule will have more dipole moment. So C is the correct option. The molecule at a different oxidation level in the following set of compounds is. If you take this molecule, this one C double bond O and carbon, that here same electronegativity 0, 0, and this one is minus 2. So this one has plus 2. Suppose if you take this one, oxygen, let's take this carbon, oxygen, and this one is carbon, this one is carbon, this one is hydrogen. Since oxygen has one bond, its contribution is minus 1. So here you have plus 1. And hydrogen less electronegative plus 1. Its contribution is minus 1. So totally 0. In this case also, we have a CC bond, two CC bonds, and one hydrogen and one oxygen. Similarly, you will get 0. Here also you have H, two carbon bonds, one H, one oxygen. So here also you will get 0. Okay, in this case only you have different oxidation state. Here plus 2, here 0, here also 0, here also 0. The structure which is not resonance structure of others in the following is. Okay, let's take this structure, this one, and this one is another resonance structure, So you are getting this resonance structure, and in latter case, this one if you take, next you will get this resonance structure. So this resonance structure is not possible. This is not resonance structures of other resonance, remaining three resonance structures. Among the following, the compound which would not be considered aromatic in its behavior. Pyridine, it's aromatic. It's not the planar, non-planar, so it's not aromatic. It's aromatic. This one also aromatic. So B is the correct option. The decreasing order of acid strength in trichloroacetic acid, acetic acid, and formic acid. Okay, as the electron withdrawing groups increases, CF3COOH. Here you have a strong electron withdrawing group when compared with CCl3COOH. So this is the order. Here you have three chlorines. The next one will be formic acid, SCOOH, and the next one is CH3COOH. Suppose if we compare the groups which are attached with COOH. Here the hydrogen neither releasing nor withdrawing, but this one is releasing, electron releasing. So this one releases electron, decreases acidity. This one withdraws electrons. This one also withdraws electrons. So they increase acidity of COOH group. What is the order? Trifluoro. Next is trichloro. Next is formic acid. Least one is acetic acid. In coming video, I will explain part 4 of general organic chemistry. Thank you.